So today in this tutorial, I'm going to explain how to find the number of input and output items from the size of a matrix. Now, what does it mean? First, let's explain that. So for that, let's see this diagram where we have an input vector and we have an output vector, and we can see there is a map. So here we have a yellow box that has some sort of rule or regulations or some governing equation, and that's why when we insert our input, it goes inside that and it gets changed and becomes y. So this is overall matrix. This is an overall system, sorry. And now let's assume that this model or this rule or regulation or governing or whatever, this can be expressed in terms of this matrix C. So our matrix C is 1, 2, 3, 1, 2, 5, 3, 4, 6. And the size of this matrix, the row by column, is gonna be 2 by 3. So we can see number of rows is 2 and number of columns is 3. And this can be represented as this equation: y is equal to this matrix C multiplied by x. So when we multiply x with this matrix, we get y. It turns x into y. But now, as I said, finding the number of input and output items from the size of the matrix. So the whole purpose of this tutorial is to show, or is to explain how we can get how many items we have in vector y and how many items we have in vector x just from this matrix. So even though it seemed like this is the dead end, we cannot go any further. Like from this diagram, this is the final state and we cannot get more information. But this matrix says a lot of things, especially what does it dimension or the row and column sizes says. That is something that we will learn. So here we can see that from the matrix we know the number of rows and number of columns, and that will tell us how many items y has and how many items x has. So the number of items in y, what would be the number of items in y, and what would be the number of items in x. So the number of items in y, or the output, would be the number of rows in the matrix, which is 2. And the number of columns of this matrix will be actually the number of items in x. So even though we start with this scenario where we just knew the matrix, we didn't know, it kind of was not explicitly provided what is the number of items in the vector x and y, we actually know that just from the matrix, and more specifically the sizes of its row and column. Now, this is why this is the equation which I have written to explain why. So from a matrix form, this is a matrix form, we can actually turn this whole thing into algebraic form. So to convert this equation from this form to the algebraic form, we need to define y and x in certain way, or define the number of items in y and x certain way, so that we can multiply the matrix in a way that 2 equations comes out. So for example, if we see on the right hand side of this equation 1, 2, 5, and the number of this is gonna be 2 by 3 matrix, and here if it is 3 by 1 matrix, so the output will be actually 2 by 1 matrix. So we have to match the dimension from left hand side and right hand side, and in the process we will get two algebraic equation. And that's why, to simplify, or if we want to just memorize for like in quick thinking, in solving bigger problems, we can just memorize these two lines. The number of items in output will be the number of rows. The number of items in input will be the number of columns. And this turns this simplified system expressed in terms of matrix C to this, where we have a couple of algebraic equation, and we have the number of items in the x vector and the number of items in the y vector. So it's important to note that we have, like, even though here we have a very simplified view and it seems like we have very less information, but we actually have far more information about the system. What are those information? First thing is that there is gonna be two different algebraic equation, or two different rules, equation making the rules how x is gonna be converted to y. So the first one is y1 is equal to x1 plus 2x2 plus 5x3, and the second one is y2 is equal to 3x1, 4x2 and plus 6x3. So this is the number of algebraic equation will be the number of items in y, and that is also equal to the number of rows of this column. On the other hand, the number of columns is going to be the number of items in the input vector x1, x2, x3. It also says that the overall system, even though we can see that our output is y1 and y2, so we have just two equation, and we have three unknown input vector. So in case we are interested in determining the number of input, or what are the inputs in our system, we can understand from this matrix that it's not, we cannot actually find all of this. Like, we cannot find unique solution of all of this unit, of the unit input items. But if it were a 3 by 3 matrix, say C were a 3 by 3 matrix, there were one more row, then the number of items of y would be 3, and the number of items of the input would be 3 as well. But most importantly, the number of algebraic equation defining the governing of this whole mapping would be 3 as well. So then we will be able to totally solve those algebraic equation to find what are the input. So we totally know what are the output. So say we have a sensor and that measures the output. So output y1, y2. And right now with this system, we cannot actually find out what are all those three input that are resulting to this y1 and y2. But if there were another sensor, if we could establish another sensor that kind of relates x and y, then instead of two sensors, using three sensors would provide us three algebraic equation, and we will be able to find out three input values.